Hello students, welcome to my YouTube channel Electrical Engineering. In this lecture, I am going to demonstrate the implementation of two-variable Newton Raphson method for solving multi-dimensional nonlinear equations. The two-variable Newton Raphson method is very much identical to single-variable Newton Raphson method. The only difference is that we have more than one functions whose solutions is to be determined. So in this way, we have several mathematical functions and this f of x will become a column vector as a result. Similarly, the right hand side is the column vector of zeros and this is the delta x, which is x minus x naught. And when I try to solve this set of nonlinear equations using Newton-Raphson method, I will apply the Taylor series. The only difference is that in single variable Newton-Raphson method, we were having a derivative term of that single mathematical function over here. In this case, we have several mathematical nonlinear functions. So this derivative term will be replaced by this matrix, and this matrix has derivative terms of each mathematical function with respect to all the variables. And this matrix of derivative terms is called Jacobian matrix. So for this case, when we have two variables in our nonlinear equation set, this Jacobian matrix will have the form partial f1 over partial x1 at x naught and partial f1 over partial x2 at x naught, partial f2 over partial x1 at x naught, and partial f2 over partial x2 at x naught. Again, in this case, this f of x will be equated to 0 and the new value of x will be calculated using this expression. So in this way, we can first calculate delta x and that delta x will be added to this x naught. So this whole term is actually delta x and this delta x is added to x naught to obtain x1. In order to implement this multivariable Newton-Raphson method, first we have to generate a function m file and we have to write these commands in that function and that function has to be saved. Here y1 is representing our first equation, y2 is representing our second equation, and this is our first equation. This one will be shifted towards left, and again this one is also shifted towards left, and both at the right sides of both the equations we will have 0. These two equations are written in this way in this function m file, and these are the elements of the Jacobian matrix. The derivative of this function with respect to x1 is given as this. The derivative of this function with respect to x2 is given as this. Similarly, the derivative of this function with respect to x1 is given as this, and the derivative of this function with respect to x2 is given as this. And this file is saved, and then we will generate this main file which has to be run, and in this file this function m file will be called. So by writing these set of commands, we can calculate the solution of this set of equations. So you can see the MATLAB algorithm which is written over here. 0.5, 0.5 are the two initial values of x1 and x2. Now let's run this code. This is our required solution after 6 iterations. x1 is 1 and x2 is equal to 0. Now if I want to validate my result, I can write a small code in another file, and This file will actually plot both the functions and from -1 to 1, and the intersection of both the functions will give us the point at which the solution exists. When I run this file, I get this plot. This is x1 and this is x2. This is my first function. This dash line is my second function, and both the functions undergo intersection at this point. And at this point, my x1 is 1 and my x2 is 0. So this is the solution, and this is the same solution which I have obtained using this Newton Raphson method. X1 is 1 and x2 is 0. So hope you have enjoyed this lecture. For watching more similar videos, stay tuned to my YouTube channel. Until the next lecture, it's goodbye.